This is the Requs AI edge case prediction software demonstration. The very first thing we do is identify what could go wrong. Our example is a traffic light, a regular green traffic light. There's three basic hazards that it can have. Collision, perhaps all the lights are green or all the lights are yellow. Traffic stalls, perhaps all the lights are red or yellow. And then the lights could be out of sync with each other. One traffic light could be out of sync with the one right next to it. We can define severity using any standard we want. For example, MIL standard 882E. We could define likelihood with any standard we want. We simply assess globally what the hazard is. So if we have a collision that's catastrophic, traffic stalls and lights out of sync, for example, are serious. And so now we have at least what could go wrong with these edge cases. The next step is to import the system state design from MBSE or to type it in. You can see my system states here. The system states are the physical states. So a red bulb could be on, a green bulb could be on, a yellow bulb can be on. We're going to see when we go to look at the edge cases, it's possible because it's software controlled, more than one of these bulbs can actually be on. But this is the desired state diagram. So you can see the transitions from one light to another are dependent on the timers. So the software is actually what changes the state. It is the thing that commands the timer, which ultimately changes the states. So when constructing the state diagram, make sure you list the physical states. The software is what commands the transitions. Now we're going to identify the other things we have in the system that require fault handling. We definitely have traffic sensors. They're a key part of our system. If those aren't working, the software is going to need to know about it. We have Wi-Fi because the traffic lights communicate with each other over a national network, the TSCS, which keeps the lights in sync with each other. So if the Wi-Fi goes down, we're going to have problems keeping the lights in sync. We have sensor management that manages the readings from the sensors. That feeds into the timer management, which determines the timers of the lights. And then the control loop manages all of it. It actually turns the lights on and off depending on what the timers and the sensors are saying to do. And then our interface, data interface, is with that network. We're receiving information from the network on how to sync those lights with each other. Okay, once we press the Save Changes to the Interfaces table, this is going to generate several rows in the FMEA, or the edge case prediction. Similarly to the state diagram, there are many state-related root causes, and by setting up our state diagram, the software is going to populate those edge cases. So let's go to the Edge Case tab. It is cranking out the edge cases that apply to our light. Let's go to the first page. All right, right off the bat, TLEH1, it's looking at the fault in the traffic sensors. We could have faulty traffic sensors. We could also have faulty readings or false alarms based on too few readings from those traffic sensors, TLEH23. We could have a fault in the sensor management software, a fault in the timer software, a fault in the control loop. It could be overly sensitive there. We could have faults in the traffic sensors that aren't recovered from properly. So for example, maybe there's a fault in the sensor and the software just stops computing the timers. That would be serious overkill. So it goes through and it lists several root causes. We can see our communication faults. The software might do something silly when the communication is down instead of just going with default timers. It could fail to detect failures in each of the main software components. Maybe the timer management software has stalled. The software might do the wrong thing when that happens. So it automatically populates root causes that are specific to our traffic light here. You can see the data management here. It's looking at our interface to the TSCS network. There's a lot of things that could go wrong. We might have units that are incompatible. We might have mismatched data sizes. Anytime you have two different software components interfacing with each other, you could have an incompatible interface. Now, when we get to state management, this is listing all of our prohibited transactions. It is prohibited, or the light cannot turn from red to yellow. That's not allowed. However, the software can do anything at once. It's software. There's many different ways the software could allow that transition. And if it does, we could end up with a collision or a traffic jam. It could also transition from green to red, which would really be bad. And that if the light's green, it suddenly turns to red without going to yellow, we're going to have a collision. And it could also transition from yellow to green. That would cause a lot of confusion. People would be wondering, okay, it was supposed to turn red. How come it turned green? I don't know what to do. That could cause a lot of confusion in the traffic. We could have conditionally prohibited transitions as well, TLSM2. It could be the light makes a valid transition, let's say from green to yellow, for example, but it does it before the green timer's expired. Similarly with the other lights as well. We have other state-related failure modes. The light could get stuck in one color. That's definitely happened to me before, where the light gets stuck in green on one side and red on the other. That can happen. Software is controlling those lights. It might get into an endless loop. It could be that the lights are in the wrong color after a loss of power, after a power outage. That could certainly happen. Let's see what else we have here. There's a bunch of other root causes it goes through, but I think you get the idea here that the software basically creates root causes that are specific to our state design and to our interfaces. And next, we'll go over the software from MIA, which takes this a step further and connects the dots between the root causes and the effect on the hazards.